to another installment of the 2021 Student Development Conference hosted by the Southern African Archaeological Student Council with kind cooperation from the University of Pretoria and their ClickUp online platform. So with me today is Mpumi Maringa. She is a fellow member of council, shadow at the moment. And our very special guest for today is Karin Scott, who is an archaeozoologist. She is our resident bone lady. Karin has a master's degree in archaeology. She specialized in small faunal, small mammal collections, specifically looking at the differences between rabbits and hares in the Southern African archaeological record. So she's all about the bunnies, to quote her one presentation title specifically. So today, Karin is going to be talking to us about the basic science behind archaeozoology. So archaeozoology is, of course, a subject field of specialization. So it's a complex field, so we can't discuss everything right now. So Karin is going to give us a synopsis of all the most important aspects. And I think it's going to provide some valuable background information to some of the related faunal analysis talks that you'll see as part of this series. So without further ado, thank you, Karin, very much for joining us today. Our presenter is going to keep her camera off because of bandwidth issues, but we are going to be able to see her presentation. So thank you, Karin, and over to you.
Bones. Nope, not these ones. Not these ones either. These ones. Animal bones. The science of archaeozoology. Hi, I'm Karin, and I will be your host on this very special journey. Archaeozoology is, simply put, the study of humans with animals and animals with humans. It is also sometimes called zoo archaeology, which is the American version, but as we follow the English traditions, we call it archaeozoology. We look at all the hard parts that are left by animals who have died within the archaeological record. That is the shells, the bones, the scales, proteins, DNA, which is not hard parts, I know, but for purposes of this lecture, it is. These are just some of the topics that archaeozoologists study. The field is vast. The field is various. Take your time. Read these. It is very important to know how vast this field is. It is not just picking up a bone and telling you what it is. Some of the questions that archaeozoologists investigate are: which animals were consumed? Which animals were consumed the most and the least? Which parts were consumed and by whom they were consumed? How the animals were hunted? How they were gathered? Which habitats were exploited? Seasonal hunting camps? Animals used in rituals, animals that had symbolic significance. There are many, many questions that we ask. And every day and every month in archaeozoology, we get new questions to ask, and the answers are not always so forthcoming. What do archaeozoologists use to do this? We look at bones and other hard parts. We study all groups of animals, including mammals, birds, fish, reptile, amphibians, mollusks, and other invertebrates. In South Africa, we are so few and far between that we have in this discipline that we cannot specialize. It is very difficult for us to specialize. Overseas, we do find specialists that work only on horses, work only on fish, work only within a specific time period, like the Roman time period. It is not possible for archaeozoologists in South Africa to specialize in this manner. This is fortunate or unfortunate, depending how you look at it. Archaeozoology is a crossover discipline, so we do not only use historical documents. We use ethnographic studies, pictographic evidence, zoology, biology texts, chemical compositions, isotope signatures, DNA. We use animal behavior studies. We can use all of these documentation to fill in our gaps, to answer our questions. And remember, we are what we eat. So everything that we eat make us humans, and that we study. So let's go on and look. All animals on these pictures have hard tissues, but we are going to focus on mammals. Mammals is the common denominator. If you know your mammal bones, you can infer from the mammal bones, which is your base, anything, whether it flies, swims, hops, or creeps along the ground. If you have your mammal bones down, you will be able to identify other things in the archaeological record. Mammal classes are these: the equids, the horses; carnivores, the cats and the dogs; bovids, which include the 3 domestic bovids, sheep, goats, and cows; primates, of which we form part; and suets, which are the pigs. We will use a cow as our example in these lectures. I like to divide animals into classes that can climb trees and those that can't climb trees. This is my distinction. Animals that can climb trees have 2 bones in their forearm. Animals that cannot climb trees have 2 bones in their forearm. But the difference is that if you can climb a tree, those bones move separately from each other. If you can't climb a tree, those bones are fused or stuck together. Fused bones give you more stability and gives you strength for long, sustained running. Open bones, or bones that can move, give you fast change of movement, gives you less stability but better grip. If you put your hand out in front of you, the same as it is in the picture, with your thumb pointing towards your body, your bones in your forearm are now crossed. If you opened it up so that your thumb points away from you, the bones in your forearm are now open. If you feel your elbow, the hard bone in your elbow, that is your ulna. The ulna is the stationary one of the 2. The radius that is attached to your thumb is the one that moves when you open and close your arm. There we have it. Animals that can climb trees have 2 bones in their forearm that move independently from each other. Animals that cannot climb trees have 2 bones in their forearm that cannot move independently from each other. There are always exceptions to the rules, because goats will be goats. This does not mean they have movable forearm bones. This just means that goats are goats. Look at this picture of the horse and with you. All the bones that you have are in the horse, and all the bones that the horse have are in you. They look different because form follows function. What you do, whether you hop, whether you skip, whether you run, whether you climb, form follows function. But the basic structure of the bone stays the same. And if you know the basic structure of the mammal bone, you will definitely be able to identify animal bones in the field or then in the lab. This is called the axial skeleton. the skull, the mandible, the ribs, the vertebral column, the sacrum, and the coccyx. Not all bones in the body are identifiable up to species level. The ribs and the vertebra, except for the first two directly onto the skull, are not identifiable up to species level. They can, however, give us size. The skull and the mandible, everybody's head looks different, or every animal's head looks different, so that's obvious. The sacrum, the triangular bone between your pelvis, that is absolutely identifiable to species level, depending, of course, on what you have. You will hear me say that a lot. If I have a 2 millimeter piece of bone, and that is of a diagnostic part of that bone, it is identifiable. But then again, I can have a 20 centimeter piece of bone, and it's a mid-shaft fragment of a long bone, and I can't identify it except to say it was a large animal or a small animal. It is depending on what you have. Just a side note, for the main pictures, I use you so that you can orientate it on your body. But I don't work with humans, I work with animals. So now let's go on to the cow. The skull, pretty obviously, everything's skull looks different. Every animal has a different head. You will find in archaeological or archaeozoological collections and museums, mainly there are more skulls than skeletons. In 1977, when Elizabeth Voigt and Ina Ploeg started the archaeozoology collection at the Transvaal Museum, now the De Tong Museum of Natural History, they took over a lot of the mammal collections, bone collections that they had. And at that stage, it was believed that animals could only be identified by their skulls. And thus, when collecting happened in the field, they cut off the head, left the body in the field, and brought the head back to the museum. The head is very diagnostic because it has the horns, or it has front-facing eyes, or it has a sagittal crest. A sagittal crest is a bony ridge we find in carnivores. If you feel between the ears of your dog or your cat, you will feel this bony ridge, and that is the sagittal crest, which is very diagnostic to tell you which animal you're dealing with. Obviously, the skull and the mandible have the teeth. I am not going to go into teeth. That is a specialist subject and will take way longer than I have been given to do this lecture. Mandible, your jawbone, very distinctive shape, distinctive from what you eat, and that comes from your teeth, and that is how the mandible looks. Once again, depending on what you have, it is identifiable up to species level. Then you have the atlas and the axis. These are the first two bones of the neck, directly onto the skull. Now, if you look at the top right picture, that is the atlas, you will see that it has a hole. That hole and the little bucket shapes you see in the first top picture on the right-hand side is directly onto the crania being the skull. The backside, the caudal view, caudal meaning towards the tail of the animal, has flat articulation surfaces. Now, if you look at the two bottom pictures of the axis, you will see that the axis has a flat articulation surface with a sticky outy bit, or a dens. Dens is the Latin for tooth. This dens feeds into that hole in the atlas. On the caudal view, you can see it clearly, and that forms the brainstem, which forms the brain. These two, once again, are the only identifiable two species level vertebra that we have in the body. Now let's move on to the forearm. The clavicle, the scapula, the humerus, and the radius and ulna that you know by now. Clavicle is a modified bone, and this is not a bone that we find in the animal kingdom. It comes from the scapula, and it is in different forms in different animals. So we are not going to discuss the clavicle, as for purposes of this lecture, it only occurs within the humans, and we do not look at humans. The scapula is the only triangular flat bone in the body. It fits onto your ribs, and if you move your shoulder up and down, you will feel it moving on the back of your body. The flat part goes against your ribs, and if you look in the lateral view, that ridge, the scapular spine, is where the muscles attach. If you think of a very thin person or a very thin cow, you can see the scapula on the back of their body. It, as I said, is the only flat triangular bone in the body, and it is easy to identify even if you have only a small piece. This, again, to species level, if you have certain diagnostic features, otherwise to size level. The humerus is the only twisted long bone in the body. If you look at the cranial view on the right side, you can see the twist in the shaft. Even if you have a piece of bone, the twist is obvious and you know which bone you are dealing with. If you look at the proximal view, the head, there is a flat glide path. That is where the scapula articulates to. You can feel it in your shoulder as you move your shoulder against your scapula. And if you make a fist and you place it next to the cranial view at the bottom, the trachea, the distal view, that is how very diagnostic for the humerus. It looks like a fist. Onto this articulates the radius and the ulna. Again, we are looking at a cow, so we are looking at fused bones. The ulna is the one that sticks out at the top. The radius is the thicker, sturdier bone. If you cut the radius through, it makes a D shape, easily identified as a D-shaped bone. Now look on the medial and lateral views. You can see that the ulna touches the radius. Any place where the two bones touch, there will be a scar, a very distinctive scar. So even if you have just a piece of the radius, you can identify it as that because the ulnar scar will be present. This is your hind leg, the pelvis, the femur, the patella, the tibia, and the fibula. We will deal with the hand and the foot later. The pelvis consists out of three pieces: the ilium, the ischium, and the pubis. If you feel on the top of your hip, that bone you feel there is your ilium wing. Your pubis is right in front between your legs, and your ischium is in your bum. You don't normally feel that, but you sit on it. You once again think of a very thin cow that you've seen. You can see the ilia wings on that thin cow. Take a look specifically at the acetabulum. It is depicted in the ventral view on the left-hand side. That is your hip socket, where your femur articulates to. Now, the pubis bone can be used for sexing. In male animals, the pubis is flat to the touch, and in female animals, the pubis is square or round to the touch. This is only visible or felt, or you can feel it in single birth animals, not multiple birth animals. Thus, in cows and in humans, but not in cats and dogs, which are multiple birth animals. The femur is the only straight long bone in the body. It is very strong and very thick. Look on the right-hand side, the proximal view, the femur head, a round ball which fits into the acetabulum that I pointed out in the pelvis. This gives you your swinging leg movement. If you look at the distal view, the bottom picture on the right-hand side, there's the trachea. That is the glide path where your patella or your kneecap glides into, which gives you your lower leg movement. The tibia in your lower leg, it is the only triangular shaped long bone in the body. The tibia in animals that cannot climb trees is a single bone and it is very sturdy. In animals that can climb trees, there is a fibula present and it is only there for support. In the evolution where animals that cannot climb trees evolved their bodies, the fibula was absorbed by the tibia and the tibia became a much stronger, sturdier bone. Hands and feet. You can feel all these bones in your own hand and in your own foot. We have in the hand the small bones called the carpals, and in the foot they are called the tarsals. Meta, meaning next to, you have the metacarpals in the hand and the metatarsals in the foot. And then in your fingers, you have either 2 or 3 bones called phalanges, and in your toes the same. You can feel these individual bones. Remember that form follows function. And this is very obvious within the differences between your hand on the right and that of the dog on the left. Once again, all the corresponding bones have been colored for you to see. You will see that the dog only walks on the 3rd phalanx, the one that looks like a nail, the green bone. If you had to walk like that, you will walk on the tips of your fingers or the tips of your toes. The adaptation is not only as far as the wrist. The adaptation of these bones go right through the body. And nowhere is this more noticeable than when you look at all the animals next to each other. Now, very simplified and for purposes of this lecture only, place your hand right in front of you at the table and stand on your middle finger. Now look at your hand. Take away the shortest fingers first. First will go your thumb, then your pinky, your pointing finger, your ring finger, and finally you will be left standing on your middle finger. Now this is exactly what has happened in evolution. For purposes of this lecture, I'm going to tell you that everything started out with 5 toes. And then as form follows function, the toes that were not in use were lost. There you have the dog with 5 toes, the pig with 4 toes, the 3 toes like the hippos are not presented here. Then you have the cows with the 2 toes and the horses on the 1 toe. You can still see the remnants with the horses of the metatarsals that are being diminished by evolution. They are there, but they form very little, they have very little functions. The extreme stance of the klipspringer on the very, very tip of the 3rd phalanx is absolutely evidence of what we've just spoken about. I don't think a ballerina on point will be able to do half what a klipspringer is doing on point. The metacarpal is a very distinctive bone because of its high density. The metacarpal and the metatarsal we find very often in the archaeological record. Now look at the bottom part of that bone, the distal part. You can see two distinct articulation facets. If I cut through that bone, there will be two distinct marrow cavities within the bone, proving that it was once two distinct different bones. But as we said, fusion gives you strength. So the bones have fused together to give strength so that we can have the stance on the two fingers or the two tips of the toes as the cows walk. Quick and dirty if you are in the field, a metacarpal is D-shaped, and that shape goes right through the shaft, and the metatarsal is square-shaped or box-shaped, and that goes right through the shaft. So even if you have a mid-shaft piece, you would know what you're dealing with. The two bones in the hind foot, the tarsals, that have the most adaptation is the calcaneum and the astragalus or the talus. These bones, once again, very high density. We find them in the archaeological record, and they are absolutely diagnostic to species level, once again, depending on what you have. Why do we need to know which one is flat and which one is twisted and which one is round and that one looks like a fist? Because these lovely complete bones are not what we work with in the archaeological record. We very seldom find complete bones in the archaeological record. This is what we deal with. We deal with fragments. And that is why we have to know this is a twist, and this is flat, and this is round, and this does this, and this bone has that adaptation, because we can see it in these little fragments. And that takes years and years of analysis and training and understanding. So even if you don't think we can do anything with 2 millimeter bone fragment, you're not the expert. Your job is to bag and tag it, to send it to my lab, and I can decide whether I can do anything with it or not. And just because we cannot identify it in the present moment doesn't mean that 20 years, 30 years hence, they will not be able to. A lot of the things that Lis Pucht and Ina Plug could not identify in 1977, except to say that it is a large animal or it is a bob-3, we can now say with ease is a cow. If you look at the work done by Annie Antoinitas on Schroeder and Louisa Hutton on K2, where they did reanalysis of the faunal material, the species list doubled and tripled in some cases because we can now identify with much more ease bones, bone fragments, species, groups than that Ina could do 30 years ago. As our information increases, as our morphological work is done, as our technology increases, this extremely dynamic, ever-changing, expanding field of archaeozoology gets more and more diagnostic. We can do more. It is an extremely changeable field. Now, what do we do with these fragments? What can they tell us? What fragments cannot tell us is a much shorter list than what they can tell us. Take your time, read through these and see. And do not think that we can only find this out from identifiable bones to species level. We do not only work with IDs, we work with non-IDs. Things that you think are just fragments tell us a very big part of the story. We need everything from the field to be able to work and count and weigh and measure to see what happened on that site. You must remember archaeology is destruction. So we need everything and we need to use everything. So once again, even if you don't think it's diagnostic, you are not the expert. Send it to me, send it to the other experts, and we will decide. Now let's quickly look at taphonomy, because bones are wonderful and bones tell us a lot. But the marks on bones, what happened to those bones, tell us also quite a lot. They fill in the story. They're the color in the picture that we have. So we look at whether the bones were cut, whether they were chopped, burnt, gnawed, ingested, expelled. What happened to that bone during death, after death? And that is a fantastic science. It is a bit of a subjective because what you see is not necessarily what I see. But once again, we have so many wonderful reference materials in texts and in publications and in books that we can look at. Again, a very neglected field within South African archaeozoology. Well, a field on its own. Overseas, we have experts in taphonomy. In South Africa, we don't. But this is definitely a field that you can follow. And then, of course, there is modified bones. Bones are not only used for food. You can make combs, you can make fishhooks and flutes and musical instruments, as per Josh Pumbai's PhD thesis. Bones and their uses are varied and many. I hope you have enjoyed this lecture, and I hope you have learned something about bones. Please go back and look at every slide. Listen to what I have said, the tips on each bone, how to ID it in the field. But please remember that you have to collect everything you find in the archaeological deposit, because we cannot work with an incomplete record. And of course, archaeology is destruction. We cannot go back and re-sift and place into context what you have missed in the spoil heaps. So please be careful in the field when you're handling bones. And that is it, archaeozoology in a nutshell. I hope you have enjoyed this lecture and I hope you have learned some. And I hope I have piqued your interest to become an archaeozoologist, just maybe. We are few and far between, and the work is lots and the work is varied. So please consider it. If you would like to contact me, if you have further questions, please forward them to the SDW committee and they will send them on to me. Thank you for joining me, and I hope you have a good day further. Goodbye.
Karin, thank you so much for that. With reference to that closing slide, you should have said archaeology in a tortoiseshell, not in a nutshell. Thank you so much for that brilliant talk. Mpumi, I always go first with the questions, but today I'm not going to be rude, so you can go first today.
All right, thank you so much, Mariette. Karin, thank you so much for your presentation. It was very informative, very clear. I would like to ask you, right? Is bone analysis essential in interpreting and understanding the archaeological record?
Obviously. It is one of the most important things to understand what went on a site, how a site was used and utilized, and the culture of the people. You can do a lot with pots, and you can do a lot with structures, and I am sure you can do a lot with spatial analysis. But if you want to understand people, you have to look at what we eat and how we use and interact with animals, and the animals with the environment around us. So yes, I would say it is the most important analysis that you need to do for an archaeological site and interpretation.
Thank you.
Thanks, Mpumi. From my side, I'd like to ask, and it's kind of going to be a two-part question, because the first is about more of the qualification side of things, what do you need to become an archaeozoologist, or at least what do you need to study? Is there important differentiating factor between a Bachelor of Arts in Archaeology and a BSc in Archaeology, as we find that the differences in degree titles or types, especially in Southern Africa, does it really matter? Because obviously you're going to have to specialize post-grad. And then the second part of the question is, what do you need in terms of your personality, your interests, your let's say your work ethic? Like archaeozoology is not a glamorous field where you get complete skeletons, and well, in some cases we find complete skeletons, yes, but in the Southern African context, most of the faunal remains that we find are in the spoil heaps, in the middens. You know, archaeology is trash. So is it like people must be aware of these kinds of things? So what would be your answer on that two-part question?
Archaeozoologists worldwide come from varying backgrounds. There are straight BAs like I have. In archaeozoology, they come from science backgrounds, BScs. We have veterinarians, we have doctors, we have zoologists, we have biologists. Your background doesn't matter. It's the questions that you ask, the work that you do that matters, that distinguishes you. In South Africa, unfortunately, you cannot specialize as an archaeozoologist, thus meaning you cannot qualify with a certificate from a university that says you're an archaeozoologist. In South Africa, you get your archaeology degree with specialization in. You always have a base. There are international universities, Groningen, the Max Planck Institute, Sheffield University, where you can qualify as an archaeozoologist and your degree is bestowed upon you as that. It is not necessary. It is what is your interest. Is your interest in animals? Is your interest in the interaction of humans with animals? And then you can come to this field with any background. Science does help you. Zoology does help you. Biology does help you. Geography does help you. But it is not essential to becoming and specializing as an archaeozoologist. Well, that's the academic side. Now the personality side. Archaeology isn't glamorous. We don't do field work. Archaeozoologists don't normally do field work. If you are like me, I am not one for field work. A week a year is more than enough for me. I don't like being out in the field. I like being in my lab. And that does not make me less of an archaeologist. In my lab, I can sit and I can work systematically through bones. You even need more patience than a normal archaeologist, because you have to turn over and look at every bone piece that comes to you. So it takes a lot of patience, dedication, good eyes, and a lot of time. And you need to be able to also keep very critical records of what you're doing. So personality-wise, if you are more of an introvert and you like being on your own, you like sitting and going through stuff and not talking to many people, then archaeozoology is definitely for you. I hope that answers your question.
Yes, it does. It does. And I think you briefly touched there on another subject in terms of when doing archaeozoological work, when doing faunal analysis, you have to be very particular and very pedantic about your note keeping. But that also extends to the field, because you found some weird and funny and entertaining notes where people have tried to do their own classification on.
Oh yeah.
Yeah, some of the bones that they found. So yes. It's also good to have a sense of humor in that case then.
Oh, absolutely. Absolutely.
Okay. And Pumi, any further questions from your side?
I just wanted to add that eyesight, it goes. It really goes. But that's because I deal with the micro mammals, the very small things, so like the rats, the bats and stuff. So looking at a cow, ulna and humerus would be amazing, but when you try and look at a humerus of a rat, You need
But you
a,
can't deny that the cover you've written
magnifier or
is
something, yeah. So yeah, it is a lot of work, but it does take a lot of time and patience. But you do get the best ideas when you're sitting alone in the lab working on these things and be like, okay, it could be this, it could be that, and it's important to take those notes.
The detective part of it is what I also like. You're an investigator. And it's nice to know things off bat, but then you get this one bone and it takes you a whole day in the museum to find it. And you still
Yes.
don't find it and you don't have the answers. It's the detective part, the sniffing it out that I love.
But that's where also the complete skeletons come in handy. Like when you look at a full articulated skeleton, then you have to try and put this puzzle together and see, okay, fine, it could be this, it could be that. So
yeah. Absolutely.
So when you mention investigative work, you did mention in the beginning of your talk that it's not like Bones, the series, but it seems like there's a potential for you guys to start maybe working on a script for Netflix. And we might just make millions. Now, archaeologists don't make a lot of work, but if we can sell a nice script to Netflix, I think you're going to be able to fund research, as much research as you like.
There we go, me. Animal bone detectives.
Okay, well, thank you very much, Karin, for joining us today. That was a really great talk. And, you know, it's just such an interesting field of specialization. And I think we can spend an entire day or an entire weekend just talking about this and, you know, going into the details and going into the specifics. And yes, but thank you very much for your time. And thank you, Mpumi, for sitting in as well again.
I love it.
And then remember, guys, tuning in for this lecture to complete the little assignment. We've got pop-up quizzes for each of our lectures. And remember that we're trying to gauge your interactivity with the workshop material. So please remember to complete that and keep an eye out for the next lecture. All right. Thank you, everyone, and have a fantastic day further. Bye.
Thank you. Bye.
Bye.